We have Daniel O from Red Hat. He's a senior developer advocate for Red Hat. And he will talk about OpenTelemetry and Knative. Yeah. I will ask you to take a picture, a selfie with him. If you don't know him, it's very famous in our sector. So we will take a selfie with Daniel.
Great.
Okay.
Please, Angel. Raise your hand.
Yeah, you can raise your hand. Potete alzare le mani. Okay. Okay.
That's awesome.
Okay. The stage is yours. A big applause, please.
Thank you so much, Serena. Yeah. Hello, everybody, and buongiorno. Ciao a tutti. That's right, Kevin. Oh, yeah. I'm super happy to be here, by the way. This is my first time in Milan and Italy. And then, I'm from Boston, United States. Here it's pretty warmer than Boston. So last week, when I was in Boston, I still wear the hoodie and the sweatshirts, not this one. But here, I don't need that anymore. Alrighty, so today I'm going to really talk about OpenTelemetry and observation, and then Knative and serverless. Let's get started. So who am I? My name is Daniel Rowe. I'm working for Red Hat as a technical and like a developer advocate, specialized Java, and then a bunch of other stuff. And I've been spending a lot of time bringing more Java application into Kubernetes and then cloud, such as Google, Microsoft, and then Amazon. And then I pretty much focus on cloud-native runtime, which is Quarkus, just like on my T-shirts, and then Spring Boot and JavaScript and things like that. And outside of Red Hat, I'm Java champion and also CNCF, like a Cloud-Native Computing Foundation ambassador for the past 5 years. So here's my contact information: Twitter, LinkedIn, like a YouTube channel, and then GitHub repository and my book stuff. If you have any question about my technology and specialty and even CNCF, yeah, feel free to reach out to me. I'm more than happy to address. All right. So previously, and many decades ago, a lot of people have their own fantastic APM tool, monitoring, and then logging, tracing, things like that, like Dynatrace and AppDynamics, and then Sysdig, and then a lot of local tools. It literally allows you to monitor and trace some logs and like data, and then you have a very fantastic dashboard to show and monitor some of the issue. If you got some error like a red light, and then we need to fix the problem for the next 2 minutes or even 2 hours. That's literally IT operation team. Now you can say platform engineer or DevOps engineer or system admin. You have to do that. And what about the observability? And the people now saying, okay, you have observability with some tools or solution. So what is the difference between observability and the monitoring or tracing? So here's a good example, just like this picture. So monitoring and tracing is just looking at some data or some logs, just to see that. But however, observe is literally means you try to understand what's happening in there. So I'm going to give some very interesting example here. This is actually a World Cup last year, Japan and Spain, the game. And there are some the virtual referring, there's some error. So there's the camera, virtual camera, and keep watching and monitoring some of the goal. Oh, this is not a goal, and then they actually take that back. So if they have some different angle, this is like that. Oh, we got some wrong judgment. So this is really why we needed to observe some stuff. One of the interesting term around observability is that you need to understand and you need to expect unknown thing, unknown issue. But this is ridiculous because how do I understand? How do I expect unknown thing? Because unknown thing, literally unknown stuff. So you know unknown thing. That's really observability. So how do I do that, and how do we do that? So let me give you some example here as developer, but it's not just only developer. It's more like all software engineers and IT folks, like a platform engineer, DevOps engineer, and then like a full stack developer. So, but mainly all people who are living in the IT field, they are always wondering, so what is the health of my application? Which means my application is still running and they're ready to get processing request, and then something wrong in my stuff. If you got something wrong as a developer or operation team, what is the root cause of this problem? And then what is the performance bottleneck? What is the performance issue with that application? So developer, try to realize the business request. I'm going to develop my business application based on Java, .NET, Python, and Go, and they want to deploy the application to cloud, for example, Kubernetes, and then my job is done. However, the IT operation just starting your job, like a day 2, day 1 operations, and there's something, you got some error on the Kubernetes, and then you need to figure out, invest that problem. And this is a whole kind of stuff from your application side. And observability actually provides more insight and it gives some inspiration. If you got some error in some future, how to fix that problem, rather than, just keep looking at some error logs or some of the normal issues. So observability actually combines 3 different pillars. For example, here, metrics and logs and traces. So metrics is really many kinds of number and data. For example, CPU numbers or utilization of your memory and the number of storage. They're all kind of metrics, not only application, but also infrastructure layer, like a platform layer, and then like a virtual machine and the container on top of the Kubernetes. The logs is really your application, more or less. So application like a Java application, you're gonna store many logs. Not only print out, it's more like, here's my incoming variable from RESTful API, or here is the output when I process and retrieve the data transaction. And traces means more like microservices. So couple of decades ago, you have like a WAR file, like a monolith application. And now you're going to break down to WAR file into thousands of microservices. And the microservices is not alone. It should be connected, distributed across your cluster and cloud environment. And then you're going to trace on the microservice relationship. For example, previously I have one big giant Frankenstein monolith application, like a 10 gig WAR file. And now you're going to break down maybe 100 microservices based on Java or .NET. And then that 100 microservices should be connected in a distributed environment, which means that you keep trace the first application and second application. You put some of the error in the middle of the application, your whole entire system may be failed. It's a bad practice. So in order to avoid the cast failure, you need to trace every single application. That is trace means. There are a lot of CNCF projects, for example, open tracing or open census, allows you to trace your microservice application tracing logs. And then this is just 3 pillars actually create your observability capability in the end. And then here is a traditional approach, how application performance tool, a management tool, solve this problem. You're going to instrument your application like based on agency approach. You need to install your agent, some of your VMware server or your physical server, and then based on maybe your some third-party library on your Java project, or the standalone process running on your application server. And then that agent keep scrapping some of the logging and then sending out to centralized server. And then system admin and access that nice dashboard based on that logging server, and then try to visualize some metric data. That is really a traditional APM solution, and a provider solve this problem. This is a few step instrument data based on agent, and then keep collecting data into central server, and then processing the data to visualize some of the nice dashboard with that. The challenging for here, for end user experience and perspective, sometimes okay, so I have some vendor solution to APM stuff, and now I'm moving forward to Kubernetes as a container environment. So, but that company not going to support container environment because the container is a really immutable packaging. I cannot put in my agent into that container because the container is anytime, any soon restart, which means my agent also gone. So it's not like a static process. So that's why some of the vendors are not going to support container environment, and then you need to select another solution or vendors like a services. And this is really lacking technologies. So we need to really think about and then different way how to solve this problem to manage observability. So first of all, the open source project provide like a non-locking technology from instrument and to visualize your telemetry data. So how to get started and where we should start with this kind of stuff. As you can see here, the CNCF landscape is really good starting point to find out relevant technology and project, etc. I just select on like a tracing and monitoring section and logging as well as just some of the pillar of the observability. And I found that there are many kinds of project and platform and tools, which usually looks good and even awesome as the end user perspective. However, it's too many choices always. So when I go to some first time restaurant, for example, like a Napoleon restaurant, and I have a zero understanding the menu. However, but there are many kind of pizzas and the spaghetti and pasta. Too many choices to me. I always try to ask the server, hey, what is your recommendation? And they say, oh, it depends on, yeah, which means I cannot solve my problem. This is really too many choices. So I'm going to just narrow down and give you some inspiration. What kind of tool is to be great? So first of all, open tracing is a super popular tool and many years ago. And then this open tracing is really give you some how to trace your application regardless of what kind of language platform are you using. And then the problem is here is a really interesting cartoon here. So, we already have a 14 standard, some tool the managing the logging, tracing, or even some of our business problem. And the 14 is ridiculous. So we need to develop our more standard way, universal, centralized, and awesome new tool. Okay, let's try on it. And then a few months later, okay, now we have a 15 new standard tool. That's really happening in your side. Everybody tried, okay, we have too many tools right now, but we need to something new. And then it will replace the others. But truth is, you have another tools, and then it's more tools. So it's really happening in the open source community as well. So open census is another super popular tool, and it's actually invented by Google. And it's not only application monitoring, but also it's more like a low-level IoT like devices. You have maybe smart building where you live, so you don't need to control manually. Maybe you can just ask Alexa, okay, Alexa. Even if my 5 years daughter, she actually use Alexa a lot of time at home. She doesn't need to use a remote controller. Okay, Alexa, turn it on the TV, or like some turn on the light. Sometimes she asks the Alexa, hey, so where's my YouTube channel stuff, things like that. But the Alexa not super smart right now, unfortunately. But this is really some people try to use IoT technology and then more smart and AI ML. As an example, ChatGPT. So open source, the best thing is it's not lacking technology, but still too many choices. Even if I just showcase two different great projects, open sensors and open tracing, but still, okay, which one do I need to use that? Because currently I have no IoT edge or some low-level devices, infrastructure to run my business application. Okay, I'm going to go with the open tracing at this moment. But 6 months later, oh, we have a new business demand to deploy the small piece of application, like some POS machine in the restaurant. With that, okay, we need to scrap the data from the POS machine from restaurant in whole around Italy, but it can be done by open tracing. We needed to use open sensors. But we already implement all our application and our maintain practices based on open tracing. We need to learn something new, but my boss not going to give more money or time to me. This is another challenge for me as a developer and then also operation team. So one of the beauty of open source community and technology is actually combine a new one. But this is a really new one rather than from 14 to 15. This is from 2 to 1. Yeah, this is really happening. So OpenTelemetry is just combine the good thing from both projects, from open tracing and open sensors. So if any one of them still using open sensors or open tracing, the project is already stopped. No more pull requests, no more improvement, no more bug fix, or in terms of security or feature requests, etc. So now every engineer, contributor, and then moving forward to OpenTelemetry right now. And here's an interesting metric here. So OpenTelemetry, it does the second largest contribution just right after Kubernetes in the CNCF project. So that's a lot of people really is exciting about OpenTelemetry right now. So and then very interesting and fun fact is even if traditional the APM tool company like AppDynamics and like Sysdig and the Dynatrace, they also saying, oh, we have some OpenTelemetry compatibility. So we could use OpenTelemetry as a server communication from our existing APM tools. And they try to evolve existing APM tool to more like a Kubernetes environment, integration with the OpenTelemetry. So this is really the second largest contribution in OpenTelemetry. So here's a few things of OpenTelemetry stuff. So OpenTelemetry is the standard like open source project. It provides API to consume your telemetry data, and also it allows developer to develop the observation business logic and then some kind of capability using SDK or also gathering telemetry data. It also provides out-of-box instrumentation feature and also a vendor agnostic collector, and it's scrap the telemetry data and send it back to some logging server or tracing server, as example, Zipkin or Jaeger server, which means you don't need to abandon or get rid of your existing logging, tracing infrastructure. So sometimes you need to adopt new tools, technology. Okay, it's time to move on, which means we need to just dispose existing infrastructure and then software. You don't need to do that. OpenTelemetry just kind of liaison from new standard telemetry management, but also is sending to existing logging, tracing infrastructure at the same time. So this is some specific topic today. So how to enable serverless Java application with the OpenTelemetry? So just imagine that you're just normal application running all the time, regardless of Kubernetes or just a virtual machine bare metal. It's too obvious, which means okay, even if I don't need to have an agent, but some OpenTelemetry, some application, just keep looking at and observe my application, and then grab some telemetry data and sending back to my the telemetry infrastructure. And now I'm going to go to some nicer dashboard on top of the infrastructure and then observe and analyzing that data. It's pretty much easier and pretty much obvious, just like your previous practice. However, the serverless is something different because serverless, anytime it should be scaled down to 0. As long as you don't have any incoming network traffic, just like imagine Amazon Lambda. You can run application on Amazon Lambda or Google function and Azure function. And then that will be scaled down to 0. If you don't have any network traffic, they say hibernate or idle. And then the agent, just lost away. Where's my application? It's gone. And then once application just goes up, when they got new network traffic, and then, I already lost my way. I lost my application where it is, and then, application just coming, the new application just born. And then I don't know where is my application, new baby, because the application is just a new one. Because previously, I need to reporting to that application based on like a URL domain, like a www, like a kcityitaly.com, things like that, or static IP address. However, the serverless, when the new serverless application reborn, the previously information is gone. The new information just generated and created. But the already existing the telemetry server or the application, no chance to know that. So that's the problem, the telemetry data and then integration with the serverless. So today I'm going to try to showcase how actually solve this problem with 3 projects here. One is OpenTelemetry for the managing your telemetry data. And then I'm going to deploy my application, specifically Java application, into Kubernetes using Knative. Knative is one of the CNCF project to allow to manage your container application as a serverless behavior. So once you deploy application as a container, it will scale down to 0 in the next 30 seconds, as long as you have any incoming network traffic. And then once you got the traffic, like a RESTful API or some kind of the DB transaction, and it just warm up and start up again. And then let me really talk about Quarkus as well. So Quarkus is a new Java framework, just like a Spring Boot and then like a Java standard way. But it's pretty much focused on Kubernetes native Java application. So one of the big challenges of Java actually was born 29 years ago. At the time, it was awesome. Once you create a Java app, you can run any virtual machine, any Java virtual machine, any app server over the internet. Super awesome. However, things change a lot. The runtime environment infrastructure is already moved forward to Kubernetes with the container technology like a Docker, Podman, OCI, etc. And then Java pretty slow and heavy to run application as a container on top of the Kubernetes, specifically serverless. So serverless, one of the big challenges of serverless is a cold start strategy. So when you run serverless app after hibernation, it takes some time, sometimes a couple of seconds to start up, just start up of your infrastructure. However, if your application takes more than 10 seconds, you got a totally like a 50 seconds or 20 seconds, sometimes even more than 1 minute. But what is the people's behavior? So again, my 5-year-old daughter, she has a very bad patience. So after 1.5 seconds, it doesn't work. I'm not going to stay anymore. Okay, move away and then find another YouTube channel or video or something. Everybody's pretty get used to like a 5G or LTE, like a super fast network and internet and mobile phone and tablet PC, even desktop. So 3 seconds is too long to waiting for that. And people assume, something happening in your side. I'm not going to use that anymore or something error. So that's why the biggest challenge of serverless is the slow startup time, aka code strategy. So that's why Java is not familiar or not super preparable language and runtime on the serverless. People more really love to use like JavaScript and Golang rather than Java. So the Quarkus actually already recognized that kind of problem, and specifically cloud environment, aka Kubernetes. So Quarkus actually changed a lot. It's pretty much make it super fast on the Kubernetes environment as well as the local environment. So here are a bunch of the bullet points. I'm not going to go through every single detail. I'm going to looking around in after this session. So if you're more interested, we have a lot of Quarkus experts in the event. Like Kevin is here, so you're going to ask Kevin rather than me about Quarkus today. Yeah. Okay. So just one quick note. So Quarkus actually released a new version 3 a couple of weeks ago. And then we have a bunch of the improvement, and then specifically Kubernetes native stuff. So like the test container, automatic stand-up. Let me show you that in a live demo. And so let's jump into a live demo. So always this slide deck is a little bit boring, right? And then I really prepared the live demo. So finger crossed. I pray the demo got this early morning. Yeah, double finger crossed. Yeah. Should I say this gesture rather than this one?
That's when it doesn't work.
Okay. Oh, yeah. If it doesn't work, yeah, I'm going to say this one. Yeah, okay. Pretty good. All right. Thanks for that. Yeah. Okay. So I have already the Quarkus Java application. It's a raised version. It's very simple. If you have no experience like a Java or a program, doesn't matter. It's pretty simple. Yeah. It's too small? It's good? Okay. So it's just like imagine that like just some hello world recipe API. So here's a few hello world stuff. Okay, here's a wannabe greeting, welcome, your name. And the other one is the like my session title, distributed tracing integration with the OpenTelemetry and the Knative. And then another is I have a database, like a PostSQL database. And then this is just retrieve data from my database, like all user information, and then like some specific information here. So here is the some of the configuration, my database configuration, things like that. And I'm going to just the reason why I'm using OpenTelemetry, Quarkus actually support OpenTelemetry integration on your Java application. So very simple. I need to just 3 configuration. One is where is my the service application name, and then where is my OpenTelemetry server, and then I'm gonna enable my OpenTelemetry capability. Just 3. You can actually 2 configuration. You can just skip it, or you can even skip it application. If you skip it, it's just referring your default application artifact name, and then it assume a default local host and then default port number. And also it's a default, it's a true. You can skip it all configuration, just nothing empty. But I want to show what kind of configuration allows you make it enable your OpenTelemetry capability here. And then I have put in some few data here. So I'm from Boston, United States, and then here's my friend, I don't know, it's Natalie here. Okay, so Natalie is Milan, the local folks, and then here's Kevin, Brussels. Okay. So now I'm going to try to run my application, my local environment. First of all, I need to run using Docker, like a Docker Compose, to run my application in the backend server, which I'm going to use Jaeger. So I'm going to run using Docker Compose, try to use, just to make sure I don't have any run process at this moment. And then I'm going to try to run Docker Compose up, and then just up it. And then my Jaeger server is a default UI, like a 1668. 60 is a pretty complicated port number. And then back to the UI, and then I'm going to try to run here. So my Jaeger is a stand-up, and then I'm going to run reload it, and then only the default Jaeger query services here, not application at the moment. And I'm going to try to run my Quarkus application as dev mode, which allows me have a really good capability. I'm going to keep running my application, getting change that. And what was interesting is you can see that the container automatically stand up. And now I'm going to try to rerun Docker process. Now I have some PostgreSQL database automatically start up. So this is one of the beauty of the Quarkus when you develop data transaction programming. So Quarkus automatically start so container based on test container technology. For example, PostgreSQL or MariaDB or MongoDB or the key cloud server for security, and then like a Kafka cluster. There are many kind of container automatically start up. You don't need to even using Docker CLI or Podman. Just Quarkus automatically start up as long as you have a container runtime, which is like a Podman, Docker, etc. Okay, and then let me try to access to RESTful API, for example, which is the hello. Let me try to a little bit bigger. Try to hello, and then yeah, got distributed trading integration, and also greeting, and then hello, my name is Dan, and then when I go back to Jaeger UI, and I'm going to reload my application, and now I can see that two hello and the greetings show that, and then I'm going to find the tracing, and then I have two tracing. This is really Jaeger stuff here. And then if you try to access to person, now I'm going to three Daniel, Boston, and then Natalia from Milan, and Kevin, Brussels, and then I'm going to try to see that, and then specific data. It's all telemetry data. It automatically grabs by OpenTelemetry and then sending to my Jaeger server. Now I have a 6 operation, just like a RESTful API. And I can also see that the database SQL stuff, the Quarkus and the person. And then I'm going to go trace, and there are more trace 4. If I call once again, it should be traced like a could be 5 soon enough. Now it's a 5 that. So it's really, it's not super complicated. I just enable my OpenTelemetry on the Java application properly. It automatically integrate my not serverless, my just local application, OpenTelemetry, and to tracing server. Now I'm going to try to deploy my application to Kubernetes. First of all, here's an OC command line. You can actually kubectl as well. So I log in my namespace with OTel Knative Java namespace, which is this one. So this is OTel Knative Java. I already installed OpenTelemetry using operator on my OpenShift cluster, which is a Kubernetes cluster. And I also install Jaeger as well. And I also deploy PostgreSQL database. Now I'm going to try to deploy my application as a serverless using Knative project. So the Quarkus allows me to just set it up. Bunch of the this is my database credential. Like where is my database URL, and then username, password, and this is all about Kubernetes configuration. And then where is my Kubernetes server, and then what is the deployment configuration. Interesting is with this target, when I said Kubernetes is deploy application as just normal pod running on 24/7. When I said OpenShift, it's a specifically deploy OpenShift cluster. When I said Knative automatically deploy as serverless. Let me try to deploy first. Quarkus build. And then when I using a Quarkus CLI or Maven or Gradle command line, it automatically packaging application like a Java application packaging, and then create and generate Kubernetes manifesto YAML file automatically. When I go back to my project and under the target, and it automatically generate a Knative JSON and YAML. When I open it, you can see that Knative YAML is automatically started. And I also set up my Kubernetes OpenTelemetry setup here. As you can see, OpenTelemetry collector is one of the CR of the OpenTelemetry. It allows me to access a Zipkin server based on Jaeger or the other things, but today I'm going to be using Zipkin. And then what is my some source, my telemetry data, which is some Jaeger stuff. So let me go back to here. I'm going to open the Jaeger. This is a Kubernetes environment. Let me try to log in with my credential. Daniel O. And then once we deploy, and then it automatically detects serverless. So this is from my local. This is my here one, and you can see that this is literally Knative service name. Even if I didn't ask any kind of RESTful API, but it already detected from OpenTelemetry and is sending to my Jaeger server, because it's a tightly integration OpenTelemetry and Jaeger. But you still put in some configuration on your application side. Where is my telemetry stuff, and where is my Jaeger? So Quarkus application is pretty much easier communicate between OpenTelemetry and then the trace server based on Jaeger, but also deploy Knative automatically. And now I have here the Knative services. In the meantime, it automatically terminating the default hibernation time, scaled down to 0 is 30 seconds. Let me give it some little bit more time, and then it automatically scaled down to 0. And then I'm going to access to RESTful API, something like HTTP, and then let's try to hello and person. And then my application just scaled down to 0, just like Amazon Lambda. And I invoke new incoming network traffic, it automatically starts up just like a serverless. And then when I go back to Jaeger UI, I'm going to reload. And then now you can see that more serverless. Here, you can see that another serverless is automatically detected. So you don't need to worry about the application side. Oh, where is my target? Where is my OpenTelemetry server? Because it's automatically integration. And then when I try this one, and then now you can see that all Java application automatically show, and then you can go to like a tag process. And then maybe this is the first one, maybe the second one. And then the operation, you can see that hello, and person literally my RESTful API. I'm going to check it out, and I have one thing. If I call once again, and then it will be second soon enough. Yeah, it takes a little bit of time. So this is really how it works, and integrate G-Street tracing integration OpenTelemetry data, specifically Java application. So this is a really longer session, obviously. So I will be pack it out and slimming down. So don't worry about that. I actually make some tutorial video around this topic into my YouTube channel. So feel free to go to here. You can scanning by your mobile phone, or so bit.ly URL, Daniel TV, and then like a YouTube channel. I already put on more than 1,000 video. I think you can find any kind of video. Feel free to subscribe and then ask me any kind of like a brilliant idea. Hey, Dan, I need to run something like a Progress CI/CD, and then I'm more than happy to create some tutorial demo next 2 weeks. That's it. That's all I would have, and thanks for attending today. And I'm really running out of time. Sorry about that. Yeah.
Ok, un grande applauso. Thank you.